Compounds X, Y, and Z are in equilibrium. The diagram shows the effects of temperature and pressure on the equilibrium yield of Z. So you want to look at the question and get all of the words out that have a certain meaning. First things first, yield is of a product. You don't yield a reactant. Okay, so yield is the thing that you make. Yeah. The fact that you're yielding compound Z tells you that in your equation, compound Z has to be on the right-hand side. Okay. So compound Z has to be on the right-hand side of your arrow. So then you look at your multiple choice, everything with Z on the left has to go away. In this case, all of your Z is on the right, so that's all good. And then you have a look at your graph. They have temperature changes and pressure changes. Okay. Be careful when you're reading the graph because pressure changes are your separate lines, and then temperature changes, you're looking at it on each line. Yeah, so just be careful of that one. So first things first, just notice that when you increase the pressure, okay, so 10 is up here, 30 is here, 50 is down here. MPa is megapascals, which is 10 to the power of 6 pascals, because kilopascals is 1,000, so megapascals is 1,000,000, so 1,000 times 1,000. So as you increase the pressure, the curve is going down, and because yield is on the y-axis, as you increase the pressure, the curve is getting lower, which means that you're decreasing your yield. Yield is on the right-hand side. Z has to be on the right-hand side. So if your yield increases, that means that your equilibrium has shifted to the right. Okay, if your yield decreases, that means that increasing pressure caused a shift to the left. Okay, increasing pressure causes a shift to the left. What does the equilibrium do in response to an increase in pressure? What does
It shifts to the side with the lower moles
moles of what?
or height, like the ratio, stoichiometric, like for the equations down there. You
What do you
understand?
mean, Brian? Moles of what?
Like it's because obviously when you increase the pressure, it has to
Yeah,
counteract the reaction. I mean, so it has to
yeah,
shift
you're
to
on
the
the right
side with
track.
fewer moles,
Yeah, that's
doesn't
right.
it?
Okay, but like moles of everything or what?
No, like of that. Oh, I don't even know what I'm saying at this point.
That's all
Um,
good. What kind of molecules exert pressure? Do we talk about pressure of solids, liquids, or gases?
gases.
Yeah, okay. So I know this is all gases, but we want to use our multiple choice to apply it to any other question we might get. So pressure changes only affect an equilibrium, and Grace said moles of gas as well, so thank you for that. Um, pressure changes only affect an equilibrium if there is an unequal number of moles on the left-hand side or on the right-hand side. Because otherwise, the left-hand side has 2 moles, the right-hand side has 2 moles. There's an equal amount of pressure exerted by gases on either side. So pressure changes won't affect equilibrium. So increase in pressure decreases yield, which means it causes a shift to the left. You guys have also told me that increasing in pressure will also cause a shift to the side with less moles, which means putting 2 and 2 together, the left side must be the side with less moles. Okay. So that's sort of like saying A is equal to B and then A is equal to C, which means B must equal to C. Okay, so increasing pressure, shift to side of less moles, increasing pressure, decrease yield, so shift to the left, which means the left side must be the side of less moles. So that's your first piece of information. Okay, so we can apply that now to cross out some of the multiple choices. So A has 4, this has 2, this has 4, this has 2, this has 2, this has 4, this has 2, and this has 4. So I'm adding just the moles of the gases. And we said that the left side is the side of less moles, which means 2 is less than 4. So I immediately cross out A and B, and I have C and D left. So that's the information that I got from my pressure. Now, in terms of my temperature is going to the right. And then when I increase temperature, notice that each of my curves, they shift slightly up. Okay, so increasing temperature actually caused an increase in yield. Okay, now increasing in temperature will affect an endothermic or an exothermic reaction. Okay, so increasing in temperature causes an increase in yield, which means the reaction has shifted to the right. Okay, what kind of reaction would shift to the right in response to an increase in temperature? An endothermic reaction or an exothermic reaction?
Exothermic.
Exothermic? What's an exothermic reaction, right? Can you define it for me?
It's where heat is released.
Heat is released. Good. So if there's an increasing in temperature and you're putting more heat into the system,
It's endothermic.
it's endothermic. Okay.
Yeah.
Can you explain for me why would it be endothermic?
Because
Whenever you're explaining equilibrium shifts, you always refer to Le Chatelier's principle. So what does Le Chatelier's principle tell you? When something happens, the system moves the
system will
heat.
shift to counteract the change.
Good. So if there's an increasing in temperature, what would the system try to do to the temperature?
It's going to try and shift and decrease the temperature.
Yeah, it's going to try to shift to decrease the temperature, and decreasing the temperature means you want to remove that heat energy. And for you to remove energy, by definition, that's what an endothermic reaction does. Okay, so increasing in temperature will shift to the right for an endothermic reaction because that's the reaction that will absorb the energy. So in this case, the endothermic reaction is going to be delta H is greater than 0. So your answer for this question is going to be C.